In this class, we're going to look at cofactor. So what is that? The cofactor of a matrix. Say for instance, we have this matrix A, B, C, D. Say this is M as equal to this. What is the cofactor of M? Is like this, step by step. The first thing you must check is to make sure that what? It is a square matrix. Square matrix, it says that the numbers of rows are equals to the numbers of column. If not, you can't do cofactor. For instance, this is 2 by 2, correct? 3 by 3, 4 by 4, 5 by 5. Okay, you are good to go. But when it comes to 2 by 3, 3 by 2, 4 by 1, you can't do cofactor. That is the first thing you need to check. After that, the second thing is you find the minor of each element. We have done minor. In case you missed that class, check the video. Just a recent video in this channel. Minor. You find the minor of each element. Then you put them down. After the minor, then you need to put a sign before each minor. What is that sign? The sign says is minus 1 raised to power I plus j. What is that? Let's look at this. So to find the cofactor of m, for instance, you agree with me that this is 2 by 2. It means it's what? It's a square matrix. Good to go. The second point is get the minor of each element. The minor of A is whatever that is on this column and whatever that is on this row will disappear. This is the remaining one. That is, this and this will go. Only D will remain. So in the position of A, I put is minor. The same thing with B. B, this guy and this guy will go, is C that is remaining. I put C here. For C, this and this will go. That is B. Then for D, this and this will go. That is A. Okay? These are the minor. I'm not true. The next thing now is to apply sign. The sign we apply is saying minus 1 raised to power I plus j. What is I plus j? This is I, roll. Column is j. What roll is this? First row, right? What column? First column. It means minus 1 raised to power 1 plus 1. That is minus 1 raised to power 2 equal to 1, because minus 1 multiplied by minus 1 is 1. So it means therefore the sign we are getting from here now is plus. So we're going to put plus here. No need to put the plus because it is plus. We go for the second one. For this C, first row, second column. First row, second column. That is raised to power 3. And you agree with me, when it is odd like this, at the end of the day, we're going to have negative 1. It means this is minus 1. Then we go for the B. That is minus 1. Second row, first column. The same thing. Raised to power 3 minus 1. Odd number. Minus. This is 2, 2. That is even number. That is raised to power 4 plus 1. You can see, with this now, you can boldly say that what this is a cofactor of matrix M. So this is a cofactor of this. Why do you need this? You need it because it is a requirement for you to get the inverse of a matrix, which we are going to do later. You need to be good here before you look at what? Inverse of a matrix. Let's look at this. It says, find the cofactor of A. Cofactor of A. Let's see. To get the cofactor of A, the first thing is to make sure that this A is a 2 by 2 matrix, 3 by 3 matrix. That is, it is a square matrix. Luckily, it's a square matrix. 2 by 2 matrix is square. Okay? So, the next thing now is to get what? The minor of each element. The minor of this is to hold this all the element in the same column and row we go, the remaining one is a minor. Okay, for 2 by 2 matrix. This one the same thing, 3. This one the same thing, 2. This one the same thing, 1. So each of these is a minor of the corresponding element in the main matrix. We are not through. The next step is we look at the sign. For this sign, we say is -1 raised to power I plus j. What is I? I is a row position, while j is a column position. Okay? For instance, for this first one, as you can see, first row, first column. That is -1 raised to power 1 plus 1, which is -1 raised to power 2. And when it is even number, it means we are going to have plus here. That is plus. No need to put it. Plus 4. You want to put it, you can still put it. But no need. After that, we go for the second one. This one. First row, second column. With that one now, you see, it is odd. First, second. That is 1 plus 2 odd. Odd will produce minus. This is what? First column, second row. Odd again. To produce minus. This is what? Second row, second column. 2 plus 2, even. If you put it here, you're going to have plus. So this is plus. So this now is the cofactor of A. Okay? That is the cofactor of A. Look at this. We are asked to find the cofactor of this matrix. Okay? How do we get the cofactor of this matrix? The first thing you need to check is this matrix a square matrix or what? As you can see, it has 3 rows and also 3 columns. Because the number of rows are equals to the numbers of columns, we say this is what? A square matrix. That is the first thing. If it's not a square matrix, you cannot apply cofactor. Having established that, we go for the next. The next thing now is to find the minor of each of the elements. If you don't understand minor, go back and look at the video on minor, okay? Okay, we go for the minor of each. For this, we strike all of them out. These are the remaining elements. That is, this multiplied by this is the 4 minus this multiplied by this, that is minus 15. Which is 64 plus 15. You agree with me? This will give us 79. So 79 is the minor of these 5. Then we go for 6. For 6. All these disappear. These are the remaining elements. So we do this multiplied by this. You agree with me? Is 56. That is this multiplied by this. Minus this. Minus 1 multiplied by this is minus 1. That is 56 plus 1, 57. So here is 57. So the minor of 6 is 57. The next one is to get the minor of this one. This multiplied by this will give us minus 105. Okay? Then this will give us minus 8, which is minus 105 plus 8. And you agree with me, this will give us minus 97. So we write here now minus 97, which is the minor of this one. We go for this. That is to say, 8 multiplied by 6, that is 48, minus 15 minus this is minus 15. That is to say 48 plus 15, and you agree with me, is going to give us 63. So here we have 63. We go for that of 8. That is to say this multiplied by this, which is 40, minus this, which is minus 1. 40 plus 1 equals to 41. Here is 41. Then we go for the one of this one. This and this will produce, that is minus 75. Why this and this will produce minus 6, which is minus 75 plus 6. And you agree with me, if you work this out now, you're going to have 69. That is minus 69. We put minus 69 here, okay? So once we have done this, we go for this one. That is 6 minus 8. You agree with me? It is minus 2. We go for this 2. You can solve this without striking them out, because this might be your first time. That's why I'm doing all this, okay? So this one is this multiplied by this, that is 5, minus this, which is minus 2. So this 2 is minus 2. We go for the last one. This and this will produce 40. This will produce 42. That is minus 2. Finally, to get the cofactor of B is to change the sign. We need to use this minus 1 raised to power I plus j. I explained this before. What is it all about? The first one is first rule. That means this is the first rule, first column. First column. That is 1 plus 1. That is 2. That is minus 1 raised to power 2. This is even number. This will produce plus 1. We are not going to change the sign. Once we are through with this, we go for the second one. The second one is first row, second column. First row, second column. That is 3. Odd number. When it is odd, it's going to produce minus. So here now we put minus. So what we do normally when it comes to 3 by 3 like this, we alternate the sign. So you don't need to waste your time here. That is plus, minus, plus, minus, plus, minus, plus, minus, plus. But if it comes to 2 by 2, for instance, A, B, C, D. If you do plus, minus, you're going to make mistake. Because first row, first column, even. First row, second column, odd. Minus is okay. But this one, a trap. Second row, first column, odd. It's going to be minus. So you cannot do plus, minus, plus, minus. This one, you must work it out. But for this, if you work it out any how you want, it will arrive at plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. Okay? So therefore, we don't need to waste our time with this again. Just know that when it comes to 3 by 3 like this, it's plus, minus, plus, minus, plus, minus. So we have plus here, we had minus here. Now we are having plus here. Already we had minus 97 already. So because plus is coming in, it's going to be still minus 97. Here, remember it's plus, minus, plus, minus. Minus will come here. Plus, no need to change it. Minus will come here. This will result to plus. Then this is plus. No need to touch this. This is minus. This will go. This is plus. No need to touch. You understand? So this now is the cofactor. That is to say, plus, minus, plus, minus, plus, minus, plus, minus, just like that, okay? Then if there is a sign that was there before, just multiply them. At the end of the day, you have this. Hope you are not confused. First of all, is it 3 by 3 matrix? Is it 2 by 2 matrix? That is a square matrix, yes. Then you find the minor of each. Once you get the minors of all of these elements, you put them like this. Once you are through with that, you use plus, minus, plus, minus, plus, minus. If minus was there before, as you have minus b, you bring it plus. Minus will still remain. If you bring it minus, it will change to plus. And if it changes to plus, there's no need to put it. You just put b. That's what we are seeing here. Now, let's look at this. It says, find the cofactor of this matrix. The first thing you need to check is this a square matrix? As you can see, the number of rows are equal to the number of what? Columns. It means it's a square matrix. Therefore, we can apply cofactor on it. You must check that first. Otherwise, you can't continue. The next is to find what? The minor of each of the elements. We have done minor before. If you don't know how to find minor, you can go and check the previous videos. I will say explain that here. Here, let's put this down. The minor of 1 is remove all the elements in this column, also remove all the elements here. This multiplied by this is 15. This multiplied by this is 12. That is minus 12, giving us 3. 3. Okay? I haven't done that. The next one is we go for this particular one. This multiplied by this, you agree with me, is minus 10. This multiplied by this is minus 28. That is minus 10 plus 28. You're going to have 18. Okay? The next one now is to go for that of 0. This multiplied by this, that is 6. This multiplied by this is 21. If you do this, you're going to have minus 15. Minus 15. Let's go for minus 2. For this minus 2, we start out this. This is minus 5. Minus this is 0. So we're going to have minus 5. We go for 3. That is 5 minus 0. That is 5. We go for this. That is minus 3 minus this is minus 7. Minus 3 plus 7. You agree with me, you're going to have 4. So here is 4. The next thing now is we go for 7. Okay? It means here, all of them will go. This and this will produce 4. This and this will produce 0. That is minus 0. That is 4. We remove all this. This will produce minus 4. This will produce 0. That is minus 4. Next one, we remove this. This will produce 3 minus this will produce 2. That is 1. I have calculated the minor for each of the elements. We apply the sign. What sign is that? Minus 1, I plus j. What is I? I is the row position, while j is the column position. This one will give us minus 1. Its position is 1, 1. That's 1 plus 1. That is minus 1 raised to power 2. We produce 1. So it's plus 1. No need to change the sign. For this one now is first, second. That is first, second. 1 plus 2. That is 3. Produce minus. We put the minus. So for 3 by 3 matrix, you have to alternate the sign. But when it comes to 2 by 2, you must calculate this out. Otherwise, you're going to make mistake. I've actually explained that. So therefore, this is plus, minus, plus. Plus and this minus will produce what? Minus. No need to change it. Plus. Or what I should do now, let me just go straight, put plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay? That is plus and plus that was here before now. All you have to do, it will still remain plus. This will be minus. Plus and minus is minus. This is minus minus will be plus. Okay? Plus plus will be plus. This is minus. This is plus 4. Minus minus is plus. This is plus 1. So this is the cofactor of this matrix. If this is A now, of A. Hope you understand this. Thank you for viewing.